So thank you, Patrick, for that overview. I'm going to jump back into the nutshell, and it's a very complex story, which is by nature difficult to tell with a singular voice, so I'm going to try my best. As we navigate this land transition in the San Luis Valley, we are obviously going to be faced with the question of what next? What do these dryland systems become? And that's where this revegetation piece comes in. And really at the center is this idea of headwaters responsibility. We are at the very tippy top of the Rio Grande, and though it doesn't get as much legislative attention and money and funding and news coverage as the Colorado, it is a beautiful river. There are many songs written about it. It's an inspiration, and it serves two states downstream from us, as well as 2 nations. So this idea that we have a responsibility to our watershed at the headwaters to manage the ecology and the hydrology is a multi-stakeholder issue, one that feeds into future generations. So again, head of the parrot. This yellow covering that you see is our aquifer system. So you can see that while we have surface waters coming from the San Juans here on the west, and Cortez, we're somewhere over here, we have water coming down into the valley. And we have the Sangre de Cristos to the east, which also contribute to some of our surface water. But most of our surface water is coming here from the San Juans and from this great underground resource, our dual-layered aquifer system. The groundwater that we withdraw from this yellow coverage interplays with our surface water, right? It's a coupled system. And it impacts the water that we deliver to the state line, so the Rio Grande compact as well. These are the sand dunes. As Patrick said, this is a testament to our erosive capacity as a valley, right? Long before humans, we had erosion, but we also had these shifting ephemeral wetlands that were in that northern part of the valley. Water that would come off of the San Juans and the Sangres would kind of shift in these ephemeral wetlands that stories say that native peoples didn't dare cross the northern part of the valley because it was so sticky and muddy and treacherous. And even in modern history, some of the producers I talked to have stories of their fathers ice skating down arroyos in the winter because the water would freeze. During the last glaciation, there was a huge lake, right? That's the source of this structure that we're talking about. It blew out, and many of those waters kind of percolated into the ground and continued to feed. This is a memory that is still in species that migrate to the valley. The Sandhill cranes, in a massive migration in early spring, come up to the valley because they remember a time where it was wetlands and this was a good breeding ground and there was food. Now many of these Sandhill cranes are kind of designated in certain protected wetland wildlife areas and also on croplands that have sufficient vegetation carried over from the previous cropping system. So stubble, barley stubble, or a winter rye crop. If it's bare, the cranes won't go there. And this is before we sort of tapped this great underground water resource for agricultural production, which changed the economy and the livelihood and the wealth and prosperity for many, many families in the San Luis Valley. But the reality is these center pivots that tapped the aquifer changed our landscape. So this is another map of the headwaters. And these orange dots down here, these are center pivots, right? Each one of them represent 120-acre circles, farms that produce food. We are the 5th largest potato producing region in the nation, second largest for fresh market potatoes. This farm here at the top grows a lot of alfalfa for our dry cattle producing neighboring states like Texas. And this image really shows how the surface water comes off of the mountains and stays in what we call a closed basin, where there's no outflow for water. And really it percolates down into the aquifer. Obviously, if you're continuing to pump out, those surface waters become less and less effective. They have less and less reach. This is important for understanding the historical context of this region that has been vastly changed by production. We grow a lot of barley, we grow a lot of potatoes, we grow a lot of alfalfa. All of these are pretty water-intensive crops. I don't know if this video will play, it's unfortunate, but I actually took this when I was driving through the valley in February, and wind speeds were high. Obviously the valley heats up before our mountain neighbors, so wind is drawn into the valley and whips across the landscape. This is like a tumbleweed, right? Classic Western cartoon, whipping across this barren circle with a center pivot in it. And at a certain point I had to stop filming because it was actually dangerous. And I was caught in this windstorm. And right next to this is images of center pivots that are in production, right? Green. This frequent tillage and disturbance of the soil definitely contributes to these wind erosive events. In Alamosa County, a couple years back, we had a 15-car pileup because the dust storm was so, dystopian, Mad Max Dune, that it was a visual imperative and a safety hazard. According to a lot of Jeff's research, the impact of this dust on snow also contributes to earlier runoff. The anecdote that Bill gave earlier is great. That's not beneficial to a lot of these agricultural regions, so they're pumping more, right? Because the water is not coming to their headgate, it's not coming to their property. You can even see on this image there's some sort of ancient flow paths that you can see where surface water had historically made it to that region. We are depleting our aquifer. And as a result, through what is a great, in my opinion, a great demonstration of democracy and people coming together, we have created the Rio Grande Water Conservation District, split into 6 subdistricts, that's the colors you see here, to manage locally water issues through incentives, through programs, and in some cases through fees. That red district, again, is Subdistrict 1. And I'm going to be focusing on Subdistrict 1 as where the majority of wells are located. Later you'll hear from Angie down in that pink district there, because it is, Sub 1 gets a lot of attention for its economic importance to many families in the valley, but it is not the only player in this idea of headwaters responsibility and surface water. Subdistrict 1 has most of the center pivot irrigation, and in order to curb the over-pumping of water, so that means pumping beyond your surface right allocation, there has been a fee system imposed, $150 an acre foot that you pump beyond what your surface rights are. Again, just by hydrology, most of the surface water is located where you can see some of those little green dots there to the west. And as you move over into that ancient alluvial fan, there's really no surface water reaching, right? It's a closed area. The water has already percolated down. So most of those pumping fees are imposed on people without those surface rights to counteract, and it's in that sort of crescent region right there. Subdistrict 1 has many programs, right, to try to incentivize this dewatering or reduced watering of these lands. This red dots that you see, again, there's the crescent, where by physical sort of constraint, people are pumping air. And so as a result, they're more likely to enter into these programs. And then up here in the sort of northwestern region, the price of water often garners more trade value than the crop that you're growing. So they're putting these lands into permanent fallow and privately trading within the subdistrict their water rights. These red circles, or these red little dots, are the Conservation Reserve Enhancement Program, CREP. It is a program that's administered by the NRCS with a singular sort of conservation outcome. It's not how it started, but like most things sort of in the conservation world, it has moved towards this idea of protecting wildlife habitat. So when you sell your well, like Patrick said, you can then enter into a CREP agreement, a 15-year contract, in which you cannot touch your land. You can't hay it, You can't hunt on it. You can't graze it. You have to use an administered seed mix by the NRCS. Very well-researched seed mix, but sort of a one-size-fits-all solution that obviously is not ground-truthed. So it's not totally working, this fee structure, right? In order to reach that 40,000 retired acres, Subdistrict 1 is putting a plan through Water Court to increase those pumping fees from $150 an acre foot to $500 an acre foot. This is in order to kind of put a market incentive, economic pressure to self-retire these lands so we don't have the state come in and similar to Idaho on the Snake Plain, where junior water rights were just shut down at the discretion of the state. This $500 an acre foot will ideally incentivize producers who do not have the wet water coming to their property or the wet water credits to offset their pumping to come out of production. Again, this is sort of the map, and I wanted to touch on this. Again, noting the crescent and the northwestern region as two kind of hot spots that we can predict. And then this map, which Seth helped me create, which shows that 40,000 acre figure reduced from the landscape. So these colored circles would all be dried up farms. This is at random, right? Obviously it's not going to look like this. It could, maybe, if the state came in. But we have some research and some data that informs there are some areas in which it would be most effective to kind of locate these dry-ups. It comes out to roughly 333 circles, and each of those circles is attached to a family, and each of those families is attached to other businesses in the valley. So we're not just talking about the dry-up of lands, we're talking about the potential dry-up of our economies and our well-being. And CSU has published a study a couple years back that showed the financial implications of these dry-ups that estimated an annual $28 million deficit every year if we are to retire this amount of lands. And obviously the concern is that dewatered lands are highly erodible. So this is actually a picture of state land board lands that have been passively revegetated, for lack of a better word, just kind of left. And we have some Russian thistle, we have some alkaline patches, definitely not that 30% ground cover threshold that we learned about earlier. And this is a picture of a fence line collecting a lot of blowing sand over by the Nissen farm. And this was actually dug out the previous year, so this is 1 year of blowing. And you can see that there was some hay bales kind of stacked in an effort to produce a windbreak. Those were there from previous years, but the dust that kept accumulating was an annual. And this is another example of sort of passive revegetation in which we kind of do get that 30% ground cover. But I want to be clear on that number, is that just because we have 30% ground cover and it doesn't blow, doesn't mean that the weeds that are growing on there aren't blowing, right? These are noxious weeds that are blowing onto neighboring fields and increasing the necessity of chemical intervention, cleaning and burning ditches more frequently because they're piling up, even accidents on roads. The vegetative cover that comprises that 30% is also very important. And then we do have the CREP model, right? That exists. And for some people, it works. You get a great payday, right? You can make about $400,000 on a circle in those 15 years where you sit and you do nothing. But really, it's only attractive to a certain demographic. Maybe you're aging out of farming and you're entering into retirement, great payday. If you have grandkids who are going to depend on that use of the land for their own livelihood, it's probably an insufficient solution. Not to mention, 15 years into a CREP contract, this is what a field looks like, where you have some four-winged saltbush, a great forage feed, but without animal intervention, it ends up very woody. it has the ability to suck watering resources from neighboring grasses. You kind of end up with alkali saccatone, Indian rice grass, four-winged saltbush. And the original species list that this was planted with, you had maybe 20 species, including flax from Washington, which that ecotype is nothing like the San Luis Valley. So there's ways that we can kind of perfect our seed mix or narrow it down or get it better suited to the lands that we're planting it in. This is another picture of a CREP field with the sangres in the background, just for some context. And another one. So the question becomes, are there alternatives? Right, on one side of the spectrum, we have do nothing, let it go, let nature handle it. And nature will handle it. It'll just be on a time scale that is irrelevant for our longevity of our communities. Or we could enter into a CREP program, which might have a good payout, but it results in this unpalatable, unusable field that is not generating any sort of applied economic value to our communities. So, we talked with a bunch of stakeholders. We got all sorts of acronyms together. We had representatives for Senator Bennett and Hickenlooper. We had county commissioners come out. We had land trusts. We had NRCS representatives. We had Rio Grande Water Conservation District employees. We all came out and we looked at these CREP fields and we kind of dreamed a little bit. And we said, what could do better? What would it look like if we put animals on here? What would it look like if we were better weed managers at the beginning? What if we put microtopography? All these kind of questions. And then we took all of those ideas and we talked to producers, because they're the ones that own these lands, right? They're our greatest conservation assets if we engage them correctly. And we kind of picked their brains and we said, well, what are your goals? Right? What do you want from this land? What is feasible for you? And if you didn't have the government telling you to do it one way, and if you had some resources, what would you like to try? And essentially what we came up with, to kind of piggyback off of the previous presentation, was this need for a revegetation playbook, right? And if this, then that sort of step-by-step guide for a multitude of revegetation pathways that satisfy social, economic, and ecologic, virtue and value. This playbook is going to have three main parts in reality. To address the social compatibility, that idea of sort of cultural compatibility, sparking change, that acceptance of solutions that Len was speaking to earlier. The ecologic viability, so experimenting with different seed mixes, and I'll get into that a little bit more later, and this economically capable piece, right, so that we continue to seek value from our drylands. Instead of seeing dry-ups as the end of the road, as like doomsday has come, what if it's a doorway to another economic return, another way of life, another way of managing land? So this idea to not fear dry land and really bolster it with economic realities of what it could be. So to address that social piece, we have decided to kind of form this integrated diagnostic framework. It's a fancy way of saying, a very socially, scientifically acceptable way of saying, you tell me, right? You tell me what, in your 30 years, in your 5 generations of working this land, what are the dry spots? What are the low spots? Do you remember what it looked like before you put in the center pivot? Do you remember what the original intent was of this land? Do you have a vision for your grandkids? And really quantifying and getting down those producer values, right? Harnessing producer innovation. I was going to put another video in here, actually, of Jan Klecker, who was trying to manage his Russian thistle by burning the field, and just really putting the resources and finances behind these producer innovations. This framework would also integrate climate data, right? Where the winds come, where the rains come, how the aquifer and its vectors and groundwater is moving under the property, so that we can inform above ground topography and try to move water, and decoding it in a way where all you have to do is work with your producer and say, let's dig a line there. Also identifying abiotic and biotic limitations of your land, of your soil. Physical, chemical, biological indicators that in very simple terms you could say, get a quart-sized baggie, get a shovel, put it in, send it off. This is what you're looking for. If you don't have the biologicals, this is how you're going to do it, but really quantifying some diagnostic staples so the landowner can use this plethora of scientific knowledge and match what their land has to the knowledge that already exists. And studying these ecologic case studies, right? This is blue grama, a great forage feed, great cover. Why is it thriving in this area? Bringing producers out there to look at it. Oftentimes they already have looked at it when they went fishing for the weekend. So just sparking those open-ended questions of what did you notice there? Should I get out there with my CSU truck and sample that soil, and do you think it'll help us? Getting these diagnostic characteristics of lands that are in successful stable states of revegetation, and again working backwards to match it to the producer. And then this second question, right, of ecologic viability is really answered by rigorous research into alternative revegetation pathways. And I like this word pathways because you're not trying to get to an end result. It integrates the process of getting there. And we're talking about generational timelines. So it is a pathway, how you start, how you adjust, how you adapt, how you move through. So alternative seed mixes, right? Are you partial to non-native seed? Could be an effective ground cover, could be an effective forage value. In a situation where you're not limited by the existing conservation programs, it might be a great option. Or planting dates. The CREP program is informed by a July planting date to try to catch our less and less frequent monsoons. When you go out into the range, native plants drop their seed in late summer and often don't get any sort of rain or snowpack until the winter. Maybe that's a better informed planting date. So trying a November planting date to try to mimic natural cycles. Also planting styles, right? Are you going to go in with a cedar? Are you going to go in all grasses first, or then are you going to interseed shrubs? When you look at the microtopography of a range, you see clusters of shrubs that harbor small grass seedlings, so maybe trying to plant shrubs strategically. Irrigation strategies. You have 3 years and 18 inches of water, which is the model that the CREP program uses, and as a result, the Rio Grande Water Conservation District, when you go into their office and you sell their well, when you sell your well to them, they give you 3 years and 18 inches to establish vegetative cover. As Patrick alluded to earlier, there's no sort of success parameters for that. So how do you use those 18 inches? Is it possible that you could use 18 inches over 5 years? Is it possible that you could synthesize some of these wetlands that used to exist in the area and create sheet ice over winter that could slowly percolate into the early spring and give those seeds that boost of water that they need at the beginning? So experimenting with other ways of putting water on. One nozzle open, one nozzle closed, synthesizing maybe various rain patterns. Noxious weed management. This is a 120-acre monoculture of Russian thistle that maybe with some foresight, I think what a lot of folks are doing is they come out of production the year before, they say, wow, that was an insane potato harvest, and then they rest, and then come summer, they make a decision to sell their well. In the meantime, this Russian thistle is growing. So how can we inform that kind of pre-revegetation strategy? How can we use animals? At this point, we could have put sheep on there and they probably would have eaten it. Now when it's all brown and pokey, it poses some challenges to manage it. Soil inoculants, this is another piece that was brought up in the earlier presentation about the role of a soil crust, right, that hardening of the surface, as well as the fungal and biological communities, relatives that live in the soil that can really produce the stable perennial environment that these seeds need to thrive. And then also this third piece, right, this economic question of what is a dryland good for? So these end uses. And this is really where the Wright-Ingraham project got exciting, is we had storytellers and architects and visual thinkers who were able to maybe jump out of that holy shit, this is happening fast reality that a lot of us, in the SLV face, and they could dream a little bit and think about what these drylands could be used for. So besides the obvious, which is if we get good forage, that 120-acre circle, right, in its modular increment could be used for grazing. There's virtual fencing. We can work and create cooperatives with our neighbors so we could move these animals through. There's the potential of maybe harvesting native seed. It might be difficult to do at scale, but what a great resource. Resilient, hardy, San Luis Valley, high elevation seed that, if established well, will certainly have applications in a very changing landscape. Increased wildfires across the West. Many of the government agencies are struggling to meet their seed demands. Greenhouses, we are in the land of the sun. We also have great geothermal resources. While this might be difficult and require some finagling with our Division of Water Resource collaborators, a good way to keep food production in the valley and maintain sort of hospitable environment. And this one also a bit controversial, but I couldn't put it in I could not put it in because there are some interests. Is how could we use this land to create energy? But my personal question is, how could we use it locally? We can't really export all of it. So is there a way that we could stimulate our local economy with the energy we produce? These are just a few, right, of this piece of, it comes back to that headwaters responsibility. And managing our water safely and responsibly in the lands that catch that water and either percolate it down into our aquifer or move it downstream. This whole project really also speaks to some of our Rio Grande water plan goals, right, of engaging informed citizens by centering them at the beginning of our research, helping inform our research objectives by their goals, as well as supporting vibrant and resilient economies, improving the overall health of our watershed. These are all very aligned with our goals that we have outlined through multi-stakeholder conversations at a state level. And then again, it's building capacity, finding the people who can find the producers, find the funding, find the other agencies and NGOs and acronyms that already exist, and bringing them all to the table so we can navigate this revegetation question without excluding anyone. It doesn't have to be a zero-sum game. It doesn't have to be do nothing or let the NRCS figure it out for you. There's going to be multiple pathways, and there was some woman who spoke here earlier who had got up and said, well, what do? I have this landscape, how do I keep my dust from blowing? And that's exactly what this revegetation playbook is hoping to address. And we have already submitted a proposal to do sort of that second piece, that revegetation questions, what seed mixes, what watering strategies, but really this idea of end uses and this producer-informed framework have implications beyond our valley, over onto the Ogallala aquifer, over into Nevada, who also struggles with blowing dust, to our neighbors down south. How do we center producers? How do we keep drylands a valuable part of our economies? We're hoping to explore that more into the future. So with that, thank you. ING up here to kind of talk about the role that people and producers play in this headwaters responsibility.